Oh, sorry. In the previous video that we just did about pavement design and Civil 3D, the audio got lost at some point, and somebody commented in the comment section, and I'm here to restore the audio for the portion that did not record audio. So we had reached at this point, and we were just talking about how to determine the thicknesses of the layers of a road. So we do not just take what Civil 3D is giving us in design of our roads. We have to design also for the pavement. So we have to determine the thicknesses of these layers and the materials to be used for those layers. Okay. So as you can see, if I select this layer and I go to properties, I can be able to see the thicknesses of the layers and all that. So the base is 0.1 meter, sub base is 0.3 meters. Okay. So how do we determine those thicknesses? So let's go back to the presentation. So I had reached at this point where I was talking about the types of rigid pavement. So you have two types: the jointed plain concrete pavement and then the continuously reinforced concrete pavement. So the jointed plain concrete pavement, which is the JPCP, usually has longitudinal and transverse joints, and then for this other one it has the longitudinal joint only. And then we had started the core of this course, which is actually the pavement design, and the three main types of ways or methods of pavement design. So you have pavement design using the local design manuals, and then you have the Ashton 1993 method, which is an empirical method, meaning it's just also confirmed through experimentation on sites or on roads. Then you have the mechanistic empirical, which is a fairly new method. So we'll be camping at the empirical method here. So let's just take a glimpse at the design using design manual. So how does this method work? So this is how it works. So you determine your SLs, your traffic load, and the subgrade strength, and through that you can be able to determine the thicknesses of the layers of your road. So let's say your traffic was 4 million SLs. So 4 million SLs lies in between the class T3. So it lies in between 3 and 10 million. You can see 10 to the power 6 here, which denotes these are millions. So T3, or 4 million rather, lies at the T3 class. And then for the subgrid, it ranges between 2 and 30 here. And as you can see, these are the various strength classes. And if your CBR is, let's say, for example, at 12, 12 is between 10 and 18, so that would be S4. So for your design of the layers of the thicknesses of your road, you just come to T3 and to S4, and you go where they meet, and you're able to get the thicknesses. So 50 is the surface, and then the base is 150, and then the sub base is 175. So the limitations of this method is that this method has a very wide range of traffic load. So 25 to 60 million is such a very big range. So let's say one person on one road you go 26 million, and on a different road you get 59, and you are assigning them the same layers. That can be a bit limiting, or a bit of an exaggeration in the lower class. Okay, so what about the empirical method, which we're talking about? So the empirical method relies on this formula for the flexible pavement, and then on this formula for the rigid pavement. So we'll be dwelling on the flexible pavement, because this is the design that is mostly used or designed in most cases. So most roads are flexible roads or flexible pavements. So for this formula, what we are trying to calculate is actually the SN. This is the structural number, because all these other variables are known. So you've carried out your traffic survey, and you have your traffic load. So the traffic load is the W18. Remember why we said 18 check out the previous video to know why it's 18 here. Then the ZR, this is a variable that depends on the reliability of the road. So if the reliability, let's say, is 75, a certain value is assigned is associated with that reliability. So the Z will be different for different reliabilities. And then the standard error usually is in between 0.45 to 0.5. So anything in between there is acceptable. Then for the change in PSI, or the present serviceability index, this is something that can be calculated from the initial serviceability index and the current serviceability index. And then the MR, this is just the resilient modulus of the subgrade. So you have all these variables, and the only unknown is the SN. So the SN that we are calculating here is the required SN for your pavement. Okay, this is the required SN, or the structural number of your pavement. So this is just defining the terms again. So W18 is the load, SN is the structural number, and this is the formula of calculating SN, which is the calculated SN. So this is the required SN. So let's say you come again and now you assign certain layers. You can come and substitute here and see whether your calculated SN is higher than the required SN. Okay, then PSI, of course, is a change in present serviceability index, and then MR is the resilient modulus. So you have this tool here that can allow you to do this design quite simply. So if I copy that tool here and I come and paste it here, and here you have the various variables. So you have your loading, let's say you've done a traffic survey and it's at 12 million. And then here the reliability, let's say it's an arterial road. I think for arterial roads, the reliability is 85%. And you can see once you change the reliability percent here, this standard normal deviate, ZR, changes. So let's say 75, you can see it's changing here. So you have different ZRs for different reliabilities. Then the combined standard error is 0.5. Let's assume the serviceability, the initial was 4.5, and then the terminal is 3. And then for the number of layers from the surface, let's just go with 2. And all this I had done, and this was what the calculation was yielding. You can see these are the variables on this side, and then these are the outputs, and it gives you a surface of 7.5, a base of 3, and a subbase of 10.5. These are inches. Okay, so let's say you are done your design with this method, this local design manual. You can come again and do a calculated structural number for these layers. Let's say you determined your road through this method. You can now come and check these layers. You just convert them into inches, and then you apply this formula to determine the structural number of the pavement. And then you compare it with the required structural number. And if it is higher or equal to that structural number, then your design is okay. So it shouldn't be too high. The difference shouldn't be that high, because that will be an over design. Also, it should just be close to this calculated structural number. So this is an example, and also where SN was the only unknown, and it was the required SN was calculated. So these are the coefficients for your road. These are the coefficients. Remember, you can calculate your SN. So for the calculated SN, you have these coefficients, A1, A2, A3. So M1 is the drainage coefficient. So this one is usually 1. So you can even remove it because it's 1. Then you remain with the thickness of the road and these coefficients. So these coefficients are here. So if you're using a base of, let's say, or a sub base of type B 12.5, the coefficient will be 0.3. So you come and multiply it with the you come and just substitute it here, and you take the depth of that sub base, and you have the part of the sub base. Okay, then you do that for the surface, and then you do that for the base also, and you get your SN. If your calculated SN is higher than the required SN, then your design is okay. So that's all about pavement design. If you like this, please remember to subscribe, please remember to like, please remember to share, please remember to leave comment. And also we have a membership in this channel, so if you want to access some limited material or some limited content, you can also access them through our membership. So please, until next time, stay safe, keep learning. Let's continue this journey. Thank you.